to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Hello and welcome. My name is Gaira Babatunde Lamin, and of course this is Learning Garage. We shall be, of course, I'm your host today. We shall be teaching mathematics. Okay, mathematics is our subject today. And of course, our topic on the mathematics would be numbers and fractions. Okay. Before we go into the topic proper, I think we need to take one or two advices, because according to the syllabus, okay, and in fact according to all the college requirements in Sierra Leone, okay, it is mandatory that everybody should pass mathematics. At least you should get a credit in mathematics. The culture of people running away from mathematics, I think we must bring it to an end. I think we must try and help the government of Sierra Leone so that we can improve in our mathematics. Okay, and of course mathematics is one of the simplest subjects in the history of this world. Okay, it only depends upon your efforts, it only depends upon how much you practice, and of course how much you are willing to take in. Okay, there are a series of big topics. We cannot just go into those topics just like that. We need foundation, and this class is especially for the senior secondary schools. Okay, that is to say whether you are in SSS1, SSS2, or SSS3. And we find it very interesting that sometimes people who say they are in SSS3 or SSS2 cannot even simplify or cannot even solve simple or basic mathematical problems. Okay, so therefore today our topic would be numbers and fractions. Okay, numbers and fractions. I think we have to start from there. What are numbers? Okay, in everyday life we see numbers, in everyday life we play with numbers, in everyday life we talk numbers. Okay, so for the benefit of all of us, we know that numbers, for example, we can demonstrate. Okay, let's take our pen tool. Okay, 1 of course is a number, 2 of course is a number, and as counting goes, we go on, we go on, we go on, we go on, okay, until infinity. Okay, you can never stop counting. You start counting, and of course, and you will never stop counting. Okay, so therefore when we talk about numbers, we refer to what? We say numbers, these are arithmetic values expressed by words, symbols, or figures representing a particular quantity. Please underline the word. Okay, representing a particular quantity. Okay, and are used in counting and making calculations. Okay, if you are asked what are numbers, we say numbers, these are arithmetic values. Okay, what are these values? Values could be represented in English numerals, like we say 4, 5, 6. Okay, so as we were saying, how does numbers appear? Somebody will say, what is this guy trying to say? Okay, we have forms in which numbers appear. Okay, they are categorized differently, just like you have biology. When you have classification of living things, okay, they classify them from plants to animals, as well as in plants again there are different subsections of plants. Okay, so therefore in mathematics also we have different values. Okay, we start with the first one. We say natural numbers. What are natural numbers? Somebody might be tempted, Are these numbers, are you going trying to say that all numbers are, or there are numbers that are artificial? No. Or are we playing with voodoo or something? That is to say, come on, I think we need the Holy Ghost here. Okay, numbers, we say these are used when we are counting, okay, just like I demonstrated. And counting or ordering, that is to say, you want to buy something, or you want to take something, or there is a huge bulk of something that you need to collect or other, okay, you can use numbers. These natural numbers, they are sometimes called whole numbers or cardinal numbers. Okay, what do we mean? Example: 1 is a natural number. Okay, 50 is a natural number. 39, okay, is a natural number. What are we trying to say now? Okay, if all these are natural numbers, right, what are those that are not natural numbers? Okay, of course, shortly we shall explain all of those numbers. Okay, the next set of ones we are going to look at is what? Cardinal numbers. They say these are numbers, or cardinal number is a number donating quantity. That is to say 1, 2, 3, just like we did. Okay, 1, 2, 3. Okay, these are cardinal numbers. Okay, and also there's other sets which are ordinal numbers. You see, most of these things we did in our primary schools and secondary schools, but we tend to forget most of these things. That's why we are reviewing before we enter proper into fractions. Okay, we say 5, 2, 4. Example. Okay, 5, 2, 4. When we say ordinal numbers, we are talking about the position of the number in a series, such as first number, second, or third number. Like for example, our 5 here is our first number. That is to say, it highlights the position. Okay, we are talking about the position of a number, okay, in series. Okay, and of course our 2 there is what? Is our second number. Okay, and of course our 4 there is representing, or is pointing at, the third, okay, set of number, or the third number in this particular series. We say whole numbers. What are whole numbers? The numbers that include natural numbers and zeros. Okay, natural number and zero, not fraction or decimal. When a number is whole, you're talking about it is not divided, there is no subsection of any number attached to it. Okay, it is full, it is complete. That is to say, we have example, we have 0. Of course, remember, it is inclusive. 0, okay, 2, 3, 4, 8, 12. Okay, these are all whole numbers. Okay, but if I have 0.025, definitely this is not a whole number. And of course, if I have a fraction which is 1/2, okay, which is equivalent also to 0.5, this is not a whole number. So therefore we say whole numbers, these are numbers that stand on their own. Okay, these are numbers that are natural numbers, including 0, okay, without having fractions or decimals. They do not exist in fraction and neither in decimal form. Integers. We say integers, these are numbers, or these are numbers that we use for counting, okay, including 0 or negative of a counting number, not fraction. Okay, not fraction, please note, not fraction, okay, or decimals. Example: we have 0, we have -2, we have -3, we have -1. Example: we have 10, we have 30. Okay, it doesn't matter whether the number is negative or positive, as the case may be, as long as it is a whole number. Okay, it might be negative, like -2 here, it is negative. Okay, but yet still it is an integer. Decimal number. We say decimal numbers, we say any number that contains a decimal point. Okay, any number that contains a decimal point, meaning if I have 1.156, okay, this is a decimal number. 0.004. Okay, we have 9.81. okay, these are all decimal numbers. Okay, as long as there is a point existing between the numbers, then it is a decimal number. Okay, rational numbers, we say a number is rational by when we obtain, or are those obtained by dividing. We say rational numbers are those obtained by dividing an integer by another integer. Okay, of course we spoke about integers. It might be positive or negative, it does not matter in this case. Okay, whether it is negative or positive, okay, it exists as an integer or can be expressed as a fraction. Okay, we say rational numbers are those obtained by dividing. Okay, let's say example, we have 2 upon 5. Okay, of course 2 is an integer, and of course 5 also is an integer. Okay, so that is 1. If I have minus 3 upon 7, okay, never mind, we have minus 3 here, but also we said minus 3 is what? Is also an integer. Okay, but it is a negative integer. That is the difference. Okay, we have positive integers and negative integers. We say positive integers that bears, of course, the positive sign, even though it is not written there, but it exists. There is a plus in front of the 2 upon 5. Okay, and also when we say minus 3 upon 7, we are talking about minus 3 there is negative, minus 3 upon 7. Okay, so therefore again we say rational numbers are those obtained by dividing an integer by another integer, or can be expressed as fractions. Now we move on to irrational numbers. What are irrational numbers? We say these are numbers that cannot be expressed as a fraction. That is to say, we have pi. Okay, we have the root of 2. Okay, therefore we cannot express example like these numbers as fractions. As we move along, we shall be including other examples so we can understand better. Okay, we are just explaining the types or the forms or the appearance in which numbers do exist. And we move on to positive numbers. We say when a number is positive, of course, it is greater than 0. Okay, of course, from back in the days when we have a number line, okay, of course these are origin 0, and of course on the right hand side we have +1, +2, +3, +4, and so on. Okay, on our left hand side we have the negative numbers like -1, -2, okay, -3, and so on. Okay, so we say a number is positive when it is greater than 0. Okay, a number is positive when it is greater than 0. Okay, and of course a number is negative when the value of that number is less than 0. Okay, just like we said there. Okay, suppose we have here -1, 2, -3, and the likes. As long as that number is less than, as long as the number is less than 0, therefore we term it as a negative number. Okay, we talk about non-negative numbers. Okay, what are these numbers? Non-negative numbers, we say these are numbers that are greater than or equal to 0. Okay, that are greater than or equal to 0. That is to say, they do not have any negative sign in front of them. Example, we have 1, we have 4, we have 17, etc. Okay, as long as all these numbers do not have any negative sign in front of them, therefore they are non-negative numbers. Okay, when we say negative numbers, we are talking about the likes of -1, -15, okay, -30, as the case may be. Okay, as long as there is a negative value, okay, there is a negative sign in front of them, therefore that number is non-negative. Negative numbers, we say these are numbers that bear the negative sign in front of them, and also 0 also inclusive is a negative number. Example, we have 0, okay, we have -4, we have minus 7. Okay, we have again example minus 14, and so on. All these numbers are non-positive. Why? Because they bear the negative value in front of them. Okay, only if it were positive, like say 2, 4, 8, example, because they all bear the positive sign. Okay, they all have positive sign in front of them, so therefore these numbers are non-positive. And also, we talk about, most times we hear the number even numbers, even, E-V-E-N, even numbers. Okay, a number is said to be an even number when what? It is divisible by 2. An integer that is divisible by 2 is an even number. Okay, example, you have 4. 4 could be divided or is divisible by 2. Okay, we have 16, it is an even number. 28, okay, is an even number. 30, okay, these are all divisible by 2. Okay, what are the numbers that are not divisible by 2? Example, we have 7. Okay, even though 2 can enter there, but there would be also a remainder. Of course, from common sense, you know that 2 can enter into 7, but there is a remainder which we are not interested in. And of course 9, okay, is not even, and of course 11, etc. Okay, so therefore all even numbers are numbers that are divisible by 2. Okay, as the case may be. We talk about odd numbers. What are odd numbers? You see, odd number is an integer that is not divisible by 2. Okay, like I pointed out there. Okay, 3 is an odd number, 7 is an odd number, 9 is an odd number, 77 is an odd number. Okay, 101, 101, etc. Okay, so all these are odd numbers. As long as they cannot be divided by 2 exactly, then we term those numbers as odd numbers. Okay, so far I think I hope we all understand different forms in which numbers appear. So stay tuned. Of course, this is Learning Garage, and of course I'm your host today, Gaiga Babatunde Lamin, and of course we are talking about numbers and fractions. We shall take a quick break, and when we come back we shall continue.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the bowl in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Hello and welcome again, and of course this is Learning Garage. Okay, this is where we fix your problems, and today we are fixing a very simple problem in our mathematics in daily life. We are talking about numbers and fractions. Okay, we spoke about the types of numbers, the way they exist, how can we express numbers, okay, in different forms. Okay, now this is just a revision. Now we are talking about fraction. Now we move on to fractions. Okay, of course fractions are commonly used. They are commonly used in everyday language to express part of a whole number. Okay, remember, a fraction is just a tip, or is just some amount of a specific or a particular whole number. Like we say, when I'm holding this pen, it is a single pen. It means that I'm holding a single pen. A number, you can say 1 pen. Okay, if I take a fraction of this pen, okay, I remove the cover there. Okay, I have taken some part of the pen. Okay, like that is to say, practically it might not be complete. Okay, it will be only complete when I put again the cover on top of the pen. Okay, then I say I have a whole pen. Okay, of course that is not expressed in our daily life. Okay, never mind. Of course, we say fractions are commonly used in everyday language to express part of a whole number. We have apple there, and of course if we divide that apple, let's say, into 4 different halves, okay, we have one side and another side there. Okay, we divide again between student 1, student 2, student 3, and student 4. Okay, so if student 1, for example, student 1 represents 1/4, okay, of the particular apple. That is to say, he only ate or took 1 part of the apple. Okay, so we represent that in fraction as 1/4. Okay, that is to say, a fraction of that. And if we take our calculator, okay, and we say 1 divided by 4, this will be our result. That is 0.25. okay, 0.25 will give us our result. That is to say, it is not a whole number. Okay, remember, we say a fraction is just part of a whole number. Okay, so we have reduced a single apple into 4 different halves. So if I say I alone, I'm going to take 3/4 of that particular apple, it is like saying I have eaten, okay, I have eaten 3 parts. Okay, I have eaten 3 parts of the apple. Okay, it only remains 1/4 of the apple. Okay, that is to say, if I do my calculations, for example, I translate that into decimals. Okay, I say 3 divided by 4, this will give us 0.75, okay, which is much larger than our previous part, which was 0.25. That is to say, I take a larger share, okay, amongst the 3 of us. Okay, so therefore we can use that information to represent, or we can use that information to translate it into fraction. Okay, remember, the numerator there is 1, and of course the denominator there is 4. Okay, so 1 is just part of the 4, okay, meaning in total it is 4 parts, and also 1 is just a fraction of the 4 halves. We say we can define fraction. How can we define fractions? We say a fraction consists of a numerator. Okay, as we said, a numerator, example, okay, we have 2, which represent our numerator here, and of course on top, which is on top, and also a denominator separated by a horizontal line. Okay, this is our horizontal line, and of course we say 3 upon example 7. Our 2 there represent what? Our numerator. Okay, whilst our 7 there represent what? Our denominator. So we said fractions are represented in this form. Okay, a numerator on top followed by a denominator underneath, wherein it is separated by a horizontal line. Okay, and of course our horizontal line there is called the vinculum. The vinculum is called the horizontal line there. Okay, that is to say, this man that is standing here, okay, it is our vinculum, which is a division sign. Okay, And of course, we say a vehiculum can represent the operation division. Okay, that is to say 2 divided. We say 2 here is divided by 7. So again, we say again, division by 0 is not possible. Okay, suppose I have 4 mangoes, of course, and I say go and share amongst nobody. Okay, go and share these mangoes amongst nobody, meaning you have 4 mangoes, you cannot share with anybody. It means that it is not possible in mathematics. Okay, that is to say, if I have 4, I divide that 4. Okay, if I divide that 4 by 0, we say this is not possible. Okay, it is not possible because we cannot divide any natural number, any integer by 0. It is never possible. If we take our calculator, for example, we demonstrate that on a calculator. Okay, we say 4 divided by 0. Guess what? We say cannot divide. Okay, it answers the question, cannot divide by 0. It is undefined. Okay, it is mathematically incorrect to say you are going to divide something by 0. Okay, any natural number, an integer, whether be it positive or negative, okay, you cannot divide that number by 0. Also, we say a fraction is defined as a upon b. Okay, that is, we are saying again another definition, a upon b, where our a and b are integers. This could be any number. Okay, a can or b can represent any number. Okay, that is, both a and b are what? Variables. Okay, they can change or they can represent any number at any given time. Okay, also don't forget, it states that where b is not equal to 0, b must never be equal to 0. Okay, b must never be equal to 0. If, for example, I say where my a is 5, where a is 5 and our b is 0, if I come to divide a upon b, this gives me what? 5 upon 0, which is undefined. Okay, it is undefined. Now we move on to the next step. We look at the types of fractions. Okay, types of fractions. Of course, our first case study there is common fractions. Okay, when we say a fraction is common, what do we mean? Common fractions. Okay, we say a common fraction is one in which the numerator is less than the denominator. Okay, when a numerator is less than a denominator, example, so that is to say 3 upon 7. Okay, our numerator there is what? 3. Okay, our denominator there is what? 7, where 3 is less than 7. Okay, if we represent that using inequality sign, we say 3 is less than 7 and our 7 there is greater than 3. Okay, so therefore whenever we have a situation like this, we say a common fraction in a fraction that has a numerator that is less than its denominator. Okay, or we call it sometimes proper fraction. Okay, we call it sometimes proper fraction. Okay, we use the term normally proper fraction. Secondly, we talk about fractions that are whole numbers. Okay, how do we get fractions that are whole numbers? We say some fractions when reduced are really whole numbers. That is, example, we have 1, okay, we have 2, 3, 4 and the likes. Okay, these are all whole numbers as we discussed earlier. We say whole numbers occur if the denominator divides into the numerator evenly. Okay, example, if we have 8 upon 8, and of course 8 will cancel itself. Okay, and the answer there is 1. So therefore 1 is a whole number. If we have another example, 15 upon 5. Okay, when we divide 15 by 5, and of course we have 5 here is 1, and 5 into 15 is 3 times. So therefore we have 3, and of course 3 is what? A whole number. 10 upon 1. Okay, 10 upon 1. Wherein, of course, remember, any number that stands alone, like for example we have 5, okay, we have 6, we have 4, these are all upon 1. These are all upon 1. Okay, never mind, it is not visible. Okay, you cannot see our 1 there. It is not represented there, but it stands with it. Okay, any number can be represented as a fraction. Okay, so if you have 10 upon 1, and of course we have 10 mangoes, we divide amongst a single person, of course it's the same as 10. Example, let's prove that one. We have 10 divided by 1. If we use our calculators, we still have the answer as what? 10. Okay. Thirdly, we talk about mixed numbers or mixed fractions. We say a mixed fraction is a combination of a whole number and a common fraction. Okay, it's a combination of a whole number and a common fraction. Example, we have 2 whole number 1 upon 3, comma, that is an example. We have 7 whole number 13 upon 5. Okay, and of course again we have 1 whole number 3 upon 2. Okay, these are all mixed fractions. Okay, it's a combination of a whole number. Okay, 2 here is a whole number, 7 here is a whole number, 1 there is a whole number. Okay, a combination of a whole number and a common fraction. Common fraction like 3 upon 2, 13 upon 5, 1 upon 3. Okay, and on our agenda we have improper fractions. Improper fractions, when we say a fraction is improper, is one in which the numerator is larger or is bigger than the denominator. Okay, example, of course earlier we spoke about what? Proper fractions. Okay, which is the opposite of improper fraction. Okay, we say again an improper fraction is one in which the numerator is larger than the denominator. Okay, the numerator there, let's say it's 7, is larger than the denominator, which is 3. Okay, this is an improper fraction. We have 10 upon 5 is an improper fraction. We have 17 upon 3, or we have 150 upon 30. Okay, 150 upon 30. We say again these are all improper fractions. Okay, say again a mixed number can be changed to an improper fraction. I go over it again. A mixed number can be changed to an improper fraction by changing the whole number to a fraction with the same denominator as the common fraction. What is this Greek trying to say here? What are we trying to say? Let's digest this one. We say when we have a mixed number, that is to say a mixed fraction, like say 2 whole number 3 upon 2. Okay, this is a mixed fraction. We say this mixed number can be changed into, or can be changed to an improper fraction by changing the whole number. Okay, this whole number, we can change this whole number, okay, to a fraction with the same denominator as the common fraction. Even if we change it, we do not lose the value of the denominator. That is to say, if I change 2 upon 3 to an improper fraction, I will have what? 2 times 2 plus our 3, okay, all upon what? 2. Okay, 2 by 2 is 4 plus 3, it is 7 upon 2. If I change this again, that is what we are trying to say. We have 2 whole number 3 upon 4. Okay, this can be changed to what? We say 4 times 2 plus 3. Okay, 4 times this man plus our numerator there. Okay, all upon what? 4. Okay, so 4 by 2, which is 8 plus 3 upon 4, and this will give us what? 8 plus 3, that is 11 upon what? 4. Okay, 11 upon 4. Okay, I hope we all understand. Let's move ahead, and before we move on, remember this is Learning Garage, and of course this is understanding fractions. Okay, finally we say what simplifying fractions. Okay, with all fractions which exist, as we have said, all type of fractions must always be simplified. You must reduce it to its lowest term. Okay, you must always reduce to its lowest term. If you do not reduce, then imagine an examination, you're going to lose marks, and of course you won't have the correct answer. Okay, note that many fractions cannot be reduced since they have no common factors. Okay, if to say you are given a fraction, of course, let me explain the first part. We say all fractions must be reduced. Example, we say 8 upon 4. Okay, it's the same as what? There is a common factor here, which is 2. 2 can enter into 4 2 times, and it can also enter into 8. How many times? 4 times. Okay, so we now have 4 upon 2, and also say we must reduce to its lowest term. Okay, 2 is common here and 2 is common here. Okay, so we have 2 upon 1, which is the same as 2. Okay, if you are given a situation wherein the factors, the fraction cannot be reduced since there is no common factor between the two numbers, which is the numerator and the denominator. Example, if you have 11, okay, upon 17, okay, there is no common factor between 11 and 17, so therefore you cannot kill yourself on that. You leave it as it is. And also, let's say we have 3 upon 5. Okay, there is no common factor that exists between 3 and 5, so therefore there is nothing that can reduce 3 and 5 at the same time. Okay, so you leave it as you see it. Okay, okay, so here is a quick exercise for you. I want you guys to please pay attention, spare 2 minutes to go over these exercises, and of course we shall take a break, and when we come back we are going to discuss. Okay, please go over them. Say which of the following are common factors. You can just mark there C, whole numbers W, mixed numbers M, or improper fractions I. Okay, I guess you can answer all of this as we have explained. So we're going for a short break. When we come back we shall join you.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the bowl in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Welcome guys, of course this is Learning Garage. We are talking fractions in mathematics. Okay, as we said, we go over again. We said we add a little exercise here. We say which says which of the following are common fractions. Okay, whole numbers, mixed numbers, or improper fractions. Okay, now let's identify which is which. Okay, we start with the first one there, which is number 1, which says 2 upon 3. Okay, 2 upon 3. Is 2 upon 3 a common fraction, whole number, mixed number, or improper fraction? Say 2 upon 3 is what? A common fraction. Okay, remember we said a proper fraction is a fraction wherein the numerator is less than our denominator. So therefore 2 here, okay, 2 there is less than our 3. Okay, so that makes it a common fraction. The second one says 3 whole number 4 upon 5. You are just to say whether this one is mixed, this one is common, this one is improper. Of course, we said again, a mixed number or a mixed fraction is one in which we have a whole number mixed with a fraction. Okay, we have a whole number there which is 3, and of course it is mixed with a fraction there which is 4 upon 5. So therefore this one is what? A mixed number. And we talk about the third one, which is 7 upon 5. The numerator there is 7 and the denominator there is 5, and of course the denominator is less than our numerator. The denominator there is less than our numerator, so therefore it makes it an improper fraction. Okay, I. Okay, and the fourth one here says 8 upon 8. If we reduce 8 upon 8, and of course we have 1 there is what? A whole number. Okay, 1 there is a whole number, so therefore our 4 there is what? Is a whole number, W. Okay, the fifth one there says what? 24 upon 2. Okay, of course there are common factors there for both numerator and denominator. Okay, for both numerator there and denominator, that is, we have 24 upon 2, wherein 2 is common here, and 2 into 24 is what? 2 into 1 is 1, 2 into 2 is 1 rather, and 2 into 4 is 2 times, so we'll have 12, and 12 is a whole number. We say 5 whole number 8 upon 19 is what? Is a mixed number. Okay, so this one is mixed. Okay, and we have 2 whole number 3 upon 3. Okay, 2 whole number 3 upon 3. Can we look at it closely? Can that one be reduced to a whole number? If so, then therefore remember you said we are told that always try to reduce our fractions. Okay, we have 2 whole number 3 upon 3. Okay, 3 by 2, that is 6, plus 3, that is 9. So we have 9 upon 3, which is equivalent to what? To 3. Okay, so 3, therefore number 7 is a whole number. Okay, our 7 there is a whole number, so this is W. 8, we say 25 upon 24. We have a denominator which is less than the numerator there, so it makes it what? An improper fraction, I. And of course 9 says what? 24 upon 25, where 24 has a numerator which is less than its denominator, and it makes it what? A proper fraction. Proper fraction there is what? A common fraction. Okay, so we represent it as C. And of course, last but not the least, we have 12 upon 12. 12 upon 12, this is equivalent to 1, so therefore this is a whole number. Okay, I think we are going into fractions proper. We look at the operating fractions. How do we operate fractions? Okay, how can we manipulate fractions when they are grouped? Okay, and the first one we said we are going to look at is addition of fractions. How do fractions operate? We operate fractions through what? Addition. Okay, we can add a couple of fractions, okay, and then we sort them out. We say adding fractions is done differently than the usual numbers. Okay, the usual way fractions appear. Normally, while adding or subtracting fractions, you will find two types of problems. Okay, the first one there is what? Where the fractions being added have the same denominator. Okay, if you experience the same denominator there, then this is one way example. Okay, these are two sets of fractions. Okay, we have 3 upon 11 and we have 5 upon 11. Okay, we say 3 upon 11, okay, plus 5 upon 11. They all bear the same denominator. So therefore, what do? When you have the same denominators, we find LCM. Okay, we find the least common multiple. Okay, the least common multiple between two addition or subtraction of fractions, okay, is the least factor, or is the least number that both denominators can enter into without any remainder. And the least common factor there is what? 11. 11 is the least common multiple there. So 11 into itself is 1. 1 times 3 is 3, plus, okay, 11 into 11 is 1 times 5 is 5. Okay, when we divide the value, we multiply to the numerator. Okay, which is to say we have 3 plus 5 upon 11. That gives us what? 8 upon 11. Okay, 8 upon 11. Can we further reduce this one? Okay, are there any common factors that exist between 8 and 11? No. If the answer is no, then we leave it like that. Okay, type 2, we say where the fraction being added have different denominators. Okay, you have different denominators, for example 1 upon 3 and also 2 upon 5. Okay, if I have 1 upon 3 plus 2 upon 5, okay, can we solve this one? Yes, we can solve using either the LCM method, or I call it as Dino equalizer. Okay, let's talk about the first one using the LCM method. Just like we said, we find two factors which are the least multiples. Okay, what are the multiples of 3? Example, multiples of 3 are what? 3 are 3, 5, 6, 9, 12, 15, okay, 18, and so on. Okay, 18, 21, and so on. What about the factors of 5? Okay, multiples of 5, you have 5, you have 10, 15, 20, okay, and the likes. So therefore we are talking about the least number that 5 and 3 can enter into without any remainder. That is 15. Okay, 15 there is the least factor. Okay, so therefore our LCM there is what? 15. If we say 3 into 15 is how many times? 5 times. 5 times 1 gives us what? 5. Okay, plus, and then 5 upon 15 there is what? 3. 3 times 2 gives us what? 6. So this is the same as what? 6 plus 5 gives us what? 11 upon 15. Okay, can we further simplify 11 upon 15? Are there any common factors between 11 and 15? No. If not, then we leave it as it is. Okay, and our second method, we talk about the Dino equalizer. Okay, I just named it like that. Of course, when we talk about Dino equalizer, we are talking about having to make both denominators on either side equal. That is to say, if I have 1 upon 3 plus 2 upon 5, okay, I look at the denominators, which is 3 and 5, then I multiply, example, this first set, I multiply this guy by, I multiply here by 5, and then also I multiply this other guy by what, 3, okay. That is to say, what I mean is that I multiply 1 by what, you say 5, 1 upon 5, 1 times 5 upon what, 3 multiplied by 5, plus again 2 multiplied by 3 all upon 5 multiplied by 3. Okay, so let's see what this gives us. 1 by 5 is 5, okay, all upon 3 by 5 is 15, plus 3 and 2 there is 6, all upon what, 5 by 3 is 15. Okay, so therefore both denominators are equal, and therefore as we have equalized them, therefore we can just add our numerators. That is to say 5, that is to say 5 there plus 6 all upon 15, which gives us what, 11 upon 15, which is the same way as we solved earlier. Okay, we are going to arrive at the same answer using either methods. Okay, so I'll prefer the LCM method, which is much shorter. Okay, how do we operate fractions using multiplication and division? We say multiplication and division of fractions are relatively easier tasks than adding and subtracting. Okay, as one may say, that is for me. Okay, multiplication of fractions is often applied in many everyday calculations in many situations, amongst to simple cancelling out of numbers. Okay, that is to say, of course, when we multiply or when we divide, we have to consider the following steps. Okay, we have to write, firstly, step number 1, please note, step number 1, okay, write all factors, write all fraction terms as numerators and denominators. Okay, you must not get mixed fractions. Okay, make sure you write them as what, numerators and denominators. Okay, write them as like that. Step 2, again, under multiplication, you make sure you cancel out, okay, common terms. Okay, cancel terms that can be simplified. Okay, you must cancel terms that can be simplified. Okay, and then of course multiply numerators with denominators. Okay, if example you have 1 upon 2 multiplied by 3 upon 7, okay, you can multiply, you can cross multiply. Okay, you can multiply 2 and 3, and then you can multiply 1 and 7. Okay, multiplying, step 4, again we say multiply denominators with numerators. Okay, you can either multiply this man to this man, numerator to denominator here, or this one in opposite directions. Okay, and then finally you write the fraction or the term as the answer. Okay, we shall give an example. Okay, you're asked to simplify 4 upon 9 multiplied by 3 upon 5. Okay, can we solve this one? Yes, we can solve this one. We have 4 upon 9 multiplied by 3 upon 5. Remember, the rule says what? You have to simplify, you have to cancel out, okay, numbers that are both numerators to denominators. Okay, you never cancel numerator to numerator. Okay, you never cancel this man to this man. Okay, you only cancel numerator to denominator on either side. Okay, on either side. We say 4 upon 9 multiplied by 3 upon 5. Okay, it's 4. We have 4 as a numerator here, and we have 3 as a numerator here. Are there any factors that are common for both 4 and any other denominator on either side? No. Do we have a common factor between 3, 9, or 3 and 5? Yes. 3 can enter into itself once and can enter into 9 2 times. Okay, that is to say 3 times 3 gives us what? 9. Okay, 3 times 3 gives us 9. Okay, so 3 can enter into 9 2 times. Okay, and of course 4 cannot enter into 2, but 2 can enter into 4. Okay, so therefore we have 2 here is 1, 2 into 4 is 2 times. Okay, so definitely have 2 multiplied by 1 upon what? 1 multiplied by 5. This gives us finally 2 upon 5, okay, as an answer. Similarly, so for question 2, okay, you're asked to solve 5 multiplied by 3 upon 7 multiplied by 1 upon 5. Okay, let's take for example, remember we can either choose the first 2 or the last 2. Okay, as long as the signs there, the relationship between them is multiplication, we can be selective. Okay, but we start with the first 2 terms. Okay, that is to say 5 multiplied by 3 upon 7. Remember, any number that stands alone is upon 1. Okay, so therefore, do we have any common factors that can cancel this man out? Okay, this is multiplied by 1 upon 5. Okay, and of course we can simplify this by saying, of course, there is a common factor here which is 5, there is a common factor here which is 5. So we have 1 times 3 times 1 times 3 times 1 all upon 1 times 7 times 1. This gives us what? 1 times 3 is 3 times 1 is 3 upon 1 times 7 is 7 times 1, which is 7. Can we further simplify 3 upon 7? No. So therefore the answer remains as 3 upon 7. Okay, ladies and gentlemen, so I think you should try out some of these ones. Okay, so finally, before we take our leave, let's look at some past questions. Remember, we are addressing the syllabus from WAEC. Okay, and of course fractions, numbers, of course these are all part of the family in mathematics. Okay, we have some past questions here which says, okay, you have to simplify. This came up was August 1991. Okay, August 1991 was says simplify 1 upon 4 to the power minus 1 whole number 1 upon 2. Again, I read again. You have to simplify 1 upon 4 raised to the power minus 1 whole number 1 upon 2. Can we solve this one? Yes, we can. Okay, let's take our time and solve this one. Okay, it's a solution. Okay, so if we break this down into bits, we start up with the mixed fraction there. We have 1 upon 4 all raised to the power minus what? 2 times 1 gives us 2 plus 1 is 3 upon 2. Okay, 3 upon 2. Okay, so can we simplify this one? Yes, we can. Okay, but remember, when you have a reciprocal of any number, that is to say, if we have example 1 upon a is equivalent to what? A raised to the power minus 1. Okay, so therefore if we have 1 upon 4 here, this is equivalent to what? 4 raised to the power minus 1. Okay, so I erase this one, and now we solve our problem. So we represent this man as what? 4 whole number, of course is a whole number, it is 4 raised to the power minus 1. Okay, all multiplied by what? Minus 3 upon 2. Okay, if I remove my bracket there, I will have 4 raised to the power minus 1 multiplied by minus 3 upon 2. Okay, if I simplify this one, of course I'll get what? 4, and of course minus and minus cancels. Okay, so minus times minus, which is plus. Okay, minus times minus is plus, of course, and then plus, we never put it in front of that, so we leave it like this. Okay, which is plus, then 1 times 3 is 3 upon 2. Okay, so this is the same as my 4. I can reduce it to what? 2 whole number, of course, I'm used to the fractions now. 2 whole number is the same as what? 2 raised to the power 2. That is to say, 2 times 2 gives us what? 4. Okay. Okay. So this is all raised to the power 3 upon 2. Again, we'll have 2 raised to the power 2 multiplied by what? 3 upon 2. Okay. And of course, we have common factors. 2 here is common, 2 here is common. Okay. So here is 1, 2 goes here 1. So we have 2 whole number of, we have 2 raised to the power 3. 2 raised to the power 3 is the same as what? 2 times 2 times 2, which gives us what? 8. Okay. So therefore, our final answer there is 8. All the fraction is being what? Reduced to a value which is 8. Okay. So I hope we understand clearly, and we'll solve one more and then I leave the rest with you. Okay, let's solve question number 2. Okay, or can we select something else which is recent? Yes, I think I'll go in for question 5, which is of a different nature. Okay, question 5 says you have to evaluate 3 whole number 1 upon 4. So I think we have something huge that we can solve here. Of course, solution. Of course, let's call this the numerator via A. Okay, and there the new denominator we say B. Okay, we are going to solve for A and B separately, and when we come, we are going to combine them and solve as a unit. Okay, we say there A is equal to what? 3 whole number 1 upon 4 multiplied by 1 whole number 3 upon 5. Okay, so if we reduce this one out, we'll have 3 times 4, which is 12. 12 plus 1, which is 13 upon 4 multiplied by 5 times 1 is 5 plus 3 there is 8 upon 5. Okay, so can we simplify this one? Yes, 4 is common here once, and 4 can enter into 8 2 times. So therefore we'll have 13 multiplied by 2 all upon 1 by 5. Okay, 13 by 2 gives us what? 26 all upon 5. Okay, so therefore our A there is 26 upon 5. Now we solve for B. Our B there says what? 11 whole number 1 upon 3. 11 whole number 1 upon 3 minus 5 whole number 1 upon 3. 5 whole number 1 upon 3. Okay, so if by solving this one, please let me just separate them. By solving this one, we have what? 11 by 3 gives us what? 33 plus 1, which is 34 upon 3 minus what? 5 by 3, or 3 times 5, 15 plus 1, which is 16 upon 3. Okay, so therefore we have LCMs which are common, so therefore the LCM there is 3, and 3 can enter into 3 is 1 times 34 gives us what? 34 minus 3 into 3 is 1 times 16 gives us 16. So therefore this gives us what? 34 minus 16 is, of course we can use our calculator. We say 34 minus 34 minus 16 gives us what? 18. Okay, so therefore we have 18. We have 18 upon 3. Okay, so 18 upon 3 is the same as what? Can 3 enter into 18? Yes, 3 into itself is 1. 18 divided by 3 gives us 6. Okay, so therefore B is equal to 6. So therefore it makes it easier, hence we say our A upon B is equal to what? 26 upon 5. 26 upon 5 divided by 6. Okay, so 26 upon 5 is what? So this gives us what? 26. We change the division sign to multiplication. That is to say, when we multiply, then we invert. We are going to invert 5 upon 26 multiplied by what? 6. Okay, if you invert this one, you leave this one constant, or invert the 6 or you change, you leave the 26 upon 5 constant. Having inverted, this gives us what? Can we simplify? This is upon 1. Okay. Can 6 enter? Can we have common values? Okay. For clarity, you say 26 divided by 6. Of course, you cannot. So we find common, which is 3. Can 3 enter into 26? We cannot. So we take 2. So 26 divided by 2 gives us what? 13. 26 divided by 2. Okay. So therefore we'll have 2 here is 3 times, and 2 here, 2 into itself is 1, into 6 is 3. So therefore we'll have 5 times 3, which is 15 upon 13. Okay, this gives us our final answer, which is equivalent also to 13 into 15. How many times is 1 times remainder 2 upon 13. Okay, so this gives us our final answer for today, and of course I'll leave you with these few problems to solve. Thank you very much for listening to me, and thank you for participating, and of course please make sure you practice these ones. Let me reduce the scale for you. Yes, you're asked to simplify, so you can simplify these questions. You try them at home, you can call your colleagues, you solve them together, whether in study camp or study group or in schools. Please make sure you practice. Remember, the success to mathematics or the success to education is about perseverance, is about practice. You cannot understand mathematics without you going through your work, you practicing. So therefore I'll leave you with this, and of course I want to say a big thank you to all of you that have spared your time to look at all the problems that we have been trying to say, we are trying to solve. I've been your host, Gaira Babatunde Lamin. This is Learning Garage. Thank you.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Alisonta Kamara.
If you mean such element, then of course we say the waters of the bowl in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction.
Star TV, tell him mama, tell him papa. Star TV, tell him sister, go tell him brother. Star TV, don't forget your granny and your grandpa. Star TV, yeah mama, 24/7. Star TV, for your games and sport, advertisement.